Okay, so yesterday we were looking at using partial fractions to integrate. So let's continue. Okay, any issues on exercise 16.3 question 8b yesterday? The one that we went through as the last question yesterday. Okay, all clear. Right, then we will move on. Okay, and let's take a look at exercise 16.3 question 9. Right, so this I think is in your textbook, page, I don't know what, 16.3, page 110. Okay, so this question says that we want to express 3x over 3x plus 5 into this particular form. I hope nobody is having the idea of cancelling out 3x because we cannot do that. We have this plus 5 over here, right? So how to achieve this form and what does the question actually mean? It means that we're trying to break it up into partial fractions, okay? If it's partial fractions, then you may be wondering why is this a p and not in the fraction form? That is because, right, notice that in this fraction itself, the degree of the polynomial are both 1 on top and at the bottom. So therefore, this is an improper fraction. Okay? Since this is an improper fraction, we need to do long division. Okay? We're taking 3x and divide it by 3x plus 5. Right? And we see 3x, 3x, so we just need a 1 multiply with 3x to get 3x. And then also we have the plus 5. So that we subtract. And eventually I get negative 5. Okay? I stop my long division when the degree of this polynomial is lesser than the degree of this. This one is degree 1, down here degree 0 already. Okay, so we stop our long division. Then now we go back to forming our partial fraction or the form that we require. So what this means is that upon long division, it will be equals to 1 minus away 5 over 3x plus 5. Okay. Okay, so in case you don't remember your long division for algebra, let's bring ourselves back to numbers. Okay, if I let's say have 165 divided by 2. Alright, how we do our long division is that 165 is inside, 2 is outside. Okay, and then we see that 1 cannot be divided by 2, so we go next digit, right? Okay, so 16 divided by 2. Okay, in order to do that we have 8 over here. So the 8 times 2 we get 16. Okay, so that's 16 minus 16. Then the 5 we bring down, okay? And in order to divide the 5 away, we need to take 2 times 2 in order to get 4, so that we have a remainder of 1, right? Okay, sometimes you rely so much on calculator, you may have forgotten how to do a long division for this. So therefore, 165 divided by 2, okay? We know that it's 82 and a half. Right? So 82 is this over here. Okay, and then half is because we have a remainder of 1 over 2. So that structure, okay, is the same one that we get over here. But this is the whole number portion, okay, and then the remainder over this divisor. Alright? Okay, so that will be for part I. I do notice that when in your WA2 for A Maths, right, when a question is being phrased this way, where it says where P and Q are integers, some of you may have misinterpreted it by following to write down what is the value of P and what is the value of Q. It is not necessary because the question did not ask you to state. Only when the question asks you to state, then you go ahead and state that, right? But this case, stopping at this presentation, okay, is already sufficient, right? Next, part 2. Okay, part 2 wants us to differentiate x ln 3x plus 5 with respect to x. Okay, so we go back to our differentiation. Alright, we see that this is a product of two things, your x and ln 3x plus 5. So we need to actually do our product rule. So keeping the left x, differentiate ln over here, we get 1 over 3x plus 5. Okay, and not forgetting to differentiate the 3x plus 5, hence we multiply by 3, and that's placed in our numerator. Okay, then we add, keeping the right side, and differentiating the x, we get a 1. Okay, so this simplifies to 3x over 3x plus 5 plus ln 3x plus 5. Been asking me how do we integrate ln. Okay, there is no rule when it comes to integrating ln. In order for us to integrate ln, there is usually always earlier parts of the question, okay, where we have to make use of in order to integrate this. Okay, in your textbook they did specify using the results in part I and part 2. Okay, whenever they ask you to differentiate something and then after they ask you to integrate, let's go into the basic step first. We know that if I were to integrate your 3x over 3x plus 5 plus ln 3x plus 5, okay, we set the foundation that this is going to be equals to the original function of x ln 3x plus 5 plus c. Okay. So we just lay this out first. Okay, so that we can observe that what we want is actually over here. Right? What this means is that we will have to then break this long integral apart, okay, into two separate integrals. And do some algebraic manipulation. Okay? So our focus is here, right? So then this part here, we move it over to the right side. So now our ln 3x plus 5 is the objective, or rather is our subject. That will be equals to x ln 3x plus 5 plus c minus away the integral 3x over 3x plus 5 dx. Okay, by the way, the noun is integral. Okay, this is what we call integral. Then the verb is your integration. Okay, so that's why know your difference between integral and integration. Just like derivative and differentiation. differentiation is an action, so it is a verb. Derivative is a noun. Okay, so a little bit of English over there. Okay, then we need to tackle this integration, okay, of 3x over 3x plus 5, and we then make use of our answer in part I. Okay, part I, we have already split it out into its two parts, okay, which is 1 minus 5 over 3x plus 5. Okay, because we cannot integrate this since the top part is not 1, okay, it is a 3x, so that's why we must do partial fractions. Okay, for tidiness, alright, for better organization, you may want to just take this out and separately integrate first. Okay, or if you don't want that, you want to do it all together, that's fine as well. But maybe just for presentation's sake, I'll do it in different colors. This is 1 minus 5 over 3x plus 5 dx. Okay. So take note there's a minus sign outside. So when I integrate, let's put our brackets around it. Integrating 1, I will get the x. Okay. This is a 5, it's just a multiple. We can bring it out of the integration, ignore it, okay, and focus on 1 over 3x plus 5. So it is minus 5. 1 over 3x plus 5 integrates to be ln 3x plus 5 and over 5. Okay, so I kept this 5 out. Okay. Right, then also not forgetting plus c, since we have just integrated this. I don't want to use a plus c to confuse the plus c over here. So for convenience, okay, drop this plus c, change everything to just a single plus c. Okay, so you don't have to deal with so many constants. Okay, yes, we oh, over 3, sorry, my bad. Thank you. Okay, then we organize things. Okay, so that will be equals to x ln 3x plus 5 minus x plus 5 over 3 ln 3x plus 5 plus d. Okay, it is possible to factorize out the ln 3x plus 5, where we have x plus 5 over 3 followed by minus x plus 3. Confident in factorizing, then don't bother with it if the question did not ask for it. Okay, questions? I think we'll end here for today. Okay, we'll wrap. I think I'll only be able to finish up chapter 16 next week. Okay, just have 2 more questions that I thought would be good to go through.